in this video, let's discuss section 4.5, inequalities involving quadratic functions. So, inequalities involving quadratic functions. Okay, so to solve the quadratic inequalities, we need to borrow some graphs knowledge. So remember that if we have a function we say fx is ax squared plus bx and plus c. If we have a function like this, we call this function a quadratic function. Of course, the leading coefficient cannot be 0. If the leading coefficient a is 0, then it's a linear function. With x squared term, it's a quadratic function. For the quadratic function, if we sketch the graph will have two basic types. Okay, so they're type 1 and type 2. Type 1, the graph will be like this. We say it has opening up. This is controlled by the sign of the leading coefficient. When the leading coefficient is a positive, it has opening up. If the sign of the leading coefficient is negative, then the graph will have opening down. Okay, the graph will have opening down. And these 2 points here, or these 2 points, are the solutions of the quadratic equations. Okay, so if here's x1, here's x2, here's x1, or here's x2, then we will say, either a is positive or negative. So in both cases, x1, x2 are solutions of the quadratic equation. What quadratic equation? Ax squared plus bx plus c equal to 0. Okay, so the intersection of the graph, this is a parabola, this is called a parabola. The intersection of the parabola with the x-axis will give us the solution of the quadratic equation, the original quadratic equations. If you do not set ax squared plus bx plus c equal to 0, if you do not set it equal to 0, we call it a function. If you set it equal to 0, we call it equation, right? Okay, and clearly we see that the solution, the number of the solutions, is determined by the discriminant, right? Remember that. The discriminant positive, 2 solutions. Discriminant 0, 1 solution. Discriminant negative, no real solution. Right? Discriminant greater than 0, 2 different real solutions. Discriminant equal to 0, a double solution. Double solution. A discriminant less than 0, no real solution. No real solution. It will have 2 complex solutions, but if we only discuss the real numbers, then there's no real solution, discriminant. So if your graph looks like this, intersect x-axis at 2 different points, then definitely the corresponding discriminant is greater than 0, right? the corresponding discriminant should be greater than 0 with respect to the current setting like this. This is the same thing. It has two intersections. Discriminant is greater than 0. If I, for example, if I sketch the parabola like this, I touch it. If I sketch the graph like this, we will see from the graph, we will see that A is greater than 0 because the opening is up, and there's only one intersection. We know B squared minus 4AC is equal to 0 because it has only one solution, one intersection. Okay, and if I get the graph like this, it does not touch the x-axis. I know A is greater than 0 and B squared minus 4AC. You see, there's no intersection, no solution. No solution means B squared minus 4AC is less than 0. Okay, so that's a basic information we need. That's a basic information we need. Okay, and another thing related to the inequality is the following. We will only discuss the case A is greater than 0. Let's assume A is always greater than 0. If A is less than 0, we will see how we handle it. A is greater than 0. Assume you have the graph like this. Then you get two solutions, x1, x2. Then between x1, x2, when x is between x1 and x2, the graph is below the x-axis. Below the x-axis means ax squared plus bx plus c. Below, less than 0. X-axis corresponds to y equal to 0. Below it, less than 0. Okay? If it's greater than x2 or less than x1, you see the graph, those two branches are above the x-axis. So x is greater than x2, greater than the right branch, or x is less than x1 or left branch, this piece or this piece. Let me get some marker. Okay, so if you have this piece and with this piece, so this is a x greater than x2 or x less than x1. For those two pieces, we see the graphs above the x-axis, so the corresponding ax squared plus bx plus c is greater than 0. It's greater than. So this is related to the solutions of inequality, quadratic inequalities. So how do we solve the quadratic inequality? First, we make sure that the leading coefficient is positive. We only discuss the leading coefficient positive case. And then we find two zeros. x1, x2, we find two zeros. If it's less than 0, if the inequality is less than 0, we're going to select the interval between those two zeros. We're going to select this piece. This is less than 0. If the inequality is greater than 0, we're going to select those yellow branch, the branches above x-axis. Greater than 0, you will have two branches. Less than 0, you will have one interval. All right, so that's the rule or the keys about this inequality. Okay, now let's try to solve it. Examples. First example, solve the inequality. Let me change mine. Solve the inequality x squared minus 4x minus 12 less than or equal to 0. Okay. Okay, so solution. We have this inequality. And the first leading coefficient is positive. It's positive 1. That's good. And then we are looking for the solution of equation. First, the solution of the equation. Equation what? X squared minus 4x minus 12 equal to 0. We first find the solution of an equation. For this one, we use the factorization cross multiplication trick. So 1, 1 here we will get a negative 6 and a 2. Negative 6 times 2 is negative 12, and you do cross multiplication. The sum is negative 4, and then you put x here, so that it can be factored as x minus 6, x plus 2 equal to 0. Okay, so do whatever trick you prefer. It's not required to always do the factorization like this. You can use a root formula or whatever method you like to find the solutions. So from here you get x is 6 or x is negative 2. 6 comes from here, negative 2 comes from here. Okay, so you have a negative 2 when you label them, and you have a 6. And remember, the leading coefficient is positive, so the graph will be like this. And you're looking for the solution set less than or equal to 0. So the solution set will be the interval. So the solution set of the inequality is from negative 2 to 6, negative 2 to 6. Because this inequality contains equal sign, so you're going to use bracket. So this is the answer. So in the solution part, this is just a copy of a problem, so you can copy or you can ignore it, and you actually only cover this piece. This is a complete part of the proof. Here is just demonstration, the supporting part. You don't have to always sketch it. But this will help you to find the solution. Okay, so step 1, make sure that a is greater than 0. Step 2, find the solutions of equation. Step 3, you're going to recall this pattern or recall the rule. What is the rule? Less than 0, between them, greater than 0, either greater than the bigger one or less than the smaller one. Okay, so that is the fixed step actually. Okay, now let's see the next example. We'll have a lot of examples today. Let's see another example. Solve the inequality. 2x squared less than x plus 10. Okay, 2x squared less than x plus 10 solution. First, this inequality, well, of course, it involves quadratic function, but the quadratic function is not in the standard form. So, which means we need to do a little bit manipulation, algebraic manipulation. We're going to move this x plus 10 from right to the left. So we will get 2x squared minus x and minus 10 less than 0. Right? So that's why we always copy the problem in a standard form at the beginning to make sure that we do have this standard form. And then we can factor it. So it's a 2 can be factored as a 2 and 1. Negative 10 can be factored as a negative 5 and times 2. And you check this. 2 times 2 is a 4. 1 times negative 5 is a negative 5. And add them together, you get negative 1. Negative 1 is exactly this midterm coefficient. Okay? So when this is correct, you put x here and x here. So it's a 2x minus 5 and x plus 2. Solve this equation. First, we solve the equation. And by this factorization, we get x is 5 over 2 or x is negative 2. Well, when we list the solutions of quadratic equations, it doesn't matter which comes first, which comes second. You can always switch the position. But when you try to get the interval, you always put the smaller number first, greater number second, right? And this is less than. And remember, this is the leading coefficient is positive, so it's always open up. Less than looks like this. So the solution set of the inequality is, here it's strictly less than, no equal sign. So it is from negative 2 to 5 over 2, and that's it. Negative 2 to 5 over 2. Open interval. All right, so that's a complete solution. So you can see that to solve the solution, to solve the quadratic inequality, mainly you just solve the quadratic equation. Once you get the quadratic equation, you go back to the little graph with the help of the graph. You can easily determine the solution of quadratic inequalities. So quadratic equation plus a graph of a quadratic function. Right? You use these two parts, you can determine the stuff. And make sure that we just want to simplify the process, simplify the rule. We always require the leading coefficient a to be positive. If a is negative, we will make it positive. All right? So let's see one case when the leading coefficient is negative. Do we have the example? Okay, for example, let me try to find a better example. If we are looking for the solution set of such stuff, of such quadratic inequality. Okay, so negative x squared plus 3x plus 10 greater than 0. You cannot first say, okay, let's find the solution of an equation, quadratic equation, and then use this property. No. This is a negative leading coefficient. of course, you can find the solution of a quadratic equation, get two solutions, but because it's negative, the graph will be flipped. So I don't want you to memorize so many different small situations. So the first step when you have a negative leading coefficient is the following. We multiply this inequality by -1. We multiply this inequality by -1, so we will get x squared minus 3x and minus 10. Okay, this one times -1 times -1 times -1. And because you multiply the inequality by a negative number, you're going to change it from greater than to less than. 0 times -1 is still 0. So you actually solve this inequality instead of the original inequality. This one is better because the leading coefficient is positive. Leading coefficient need to be positive in order to apply the rest of the steps. And then you try to factor it. You can see the -10 as a -5 times 2. And the -5 plus 2 is -3. So you get x is 5 or x is -2. And then you put a -2 here and 5 here because at this moment the leading coefficient is positive, so it's between those two solutions. And so the solution set, those two solutions, yes, the solution set of the inequality is from -2 to 5. All right, -2 to 5. Okay. Let's see more examples. Because the current example, we always have the interval between those two solutions. Let's see another example is outside two branches. Okay, let's see, we have 6x squared greater than 6 plus 5x. We're looking for the solution of this equation. Solution set of this inequality, not equation. The solution set of this inequality. So how do we do that? We move all the terms to the left side. And we can factor this. This is 6 is 3 times 2. This one is -3 times +2. I put a -3 because eventually I want a bigger negative number. So this is 2 times 2 is 4, 3 times 3 is -9. All right, this is -5, this is -5. So it's 3x, 2x. 3x plus 2, 2x minus 3 equal to 0. So x is -2/3 or x is 3/2. So -2/3, 3/2. We want it to be greater than 0, so we're going to choose either this part or this part. So the solution set is x greater than 3/2, 3/2 and above. Or use this symbol, or union, or x is less than -2/3. Right? This is the answer. Okay? So it's not very bad, right? Let's do one more. So for example, if we have let's choose greater than case greater than example, we have 2x squared minus 3x is greater than negative 9. This is problem on page 312, problem 22. Problem 22. Okay, so the first step, we organize this inequality to be the standard form, to be in the standard form. So it's a 4x squared minus 6x plus 9 is greater than 0. No, this one later. Let's discuss this one later. This one is different. Is a different type. Yeah, this is a different type. We talk about this type later. Let's see another one. Let's see another. We will come back to this example. Let's see this x squared plus 8x greater than 0. Okay, so to solve this one, you first try to factor this x squared plus 8x equal to 0. You just directly factor out x. You will get x times x plus 8 equal to 0. So x is 0 or x is negative 8. So you get a negative 8, you get a 0. You draw the parabola. And we are looking for the inequality greater than 0. So you use the right branch or left branch. So the solution set is, it is either less than negative 8, negative infinity to negative 8. Be careful, this is negative infinity. You write 8 horizontally, that's negative infinity. You write 8 regularly, that's 8. Union from 0 to positive infinity. Okay, so that's the solution set. Okay, very good, very good. So that's the example about the greater than 0. This is greater than 0. The earlier example about less than 0. Now let's try to discuss the example like this. This one. Let's see this one. We're trying to solve this in quadratic equation. Well, because I know the answer, so let's try to check the discriminant. Discriminant b squared minus 4ac. So b is negative 6. Negative 6 is a 36 minus 4 times a is a 4, c is 9, 4ac. So it's 36 minus, well, you see, 4 times 4 is 16. 16 times 9 is a big number. So it's 6 times 9, 54, 5, 144. It's negative 108. So the discriminant is negative. We know if the discriminant is negative, then what? Then this quadratic equation has no real solution. Well, this one is a complete one. It's inserted between those. Okay, so remember what will happen if this quadratic equation has no real solution under the condition the leading coefficient is positive. If this happens, if you try to sketch the graph, you see, regularly when we sketch it, we always have such a thing. But if it has no solution, we will sketch it like this. The graph does not touch the x-axis, which means the whole graph is always above x-axis. It means that for whatever input, the inequality is always greater than 0. Okay? So because of this, when the discriminant is negative, the quadratic equation has no solution. The solution set of the inequality, let me emphasize, of the inequality is a set of all real numbers. The set of all real numbers You can say from negative infinity to positive infinity, no limits, right? No limits. This is the answer. It's special, it's different. Okay, it is special and it is quite different. And of course, this one, let's recycle this example. Let's recycle this example. If we change here, this example which we put greater than negative none, we get the set is the set of a solution set of inequalities from negative infinity to positive. Whatever x, you always have this equal greater than case. But what happens if you originally get less than case? Less than case, first you organize it in the standard form, and then you solve the corresponding quadratic equation. You get b squared minus 4ac equal to negative 108 less than 0. And then you know that it is always above the x-axis. It cannot be less than 0, so the solution set of the inequality is empty, nothing. Empty, remember, empty set, we have a symbol, empty set. The solution set is empty. You can just say it is empty, or you can use this symbol. You draw a circle and cross it. Use one segment to cross it. Okay, that's the opposite case. That's the opposite case. Okay. Let's see another example. For example, if we're looking for the solution set of this inequality, we had this experience. We will check b squared minus 4ac. b is 1. b squared is still 1. Minus 4ac. 4 times 1 is 1 times 1 is, 4 times 1 is 4, and times 1 is still 4. 1 minus 4 is negative 3 less than 0. Less than 0, this implies this quadratic equation has no real solution. Quadratic equation has no real solution, plus the leading coefficient is positive. The opening is up, so it means you can imagine that the whole graph is floating above the x-axis. All the values will be greater than 0. So the solution set of the inequality is what? Is the set of all real numbers, everything. So it's negative infinity to positive infinity. Negative infinity to positive infinity, right? Let's see another example. The example is short. It's not that. Try to give you more examples because this is something subtle. This is a problem on page exercise on page 312. Problem where? Problem 18. I changed it. I changed this problem 18. Okay, I modified. Problem 18. They use the greater than 0. Now let's choose less than 0. Let's choose less than 0. Okay, be careful. Let's choose less than 0. It's not exactly problem 18. Okay, so here I will check the discriminant. B squared minus 4ac. B is 2, square is 4, minus 4a and c. 4 times 4, 16. 4 minus 16, negative 12. Less than 0. So the equation, quadratic equation, has no real solution. It has no real solution. Then again, you will imagine, whenever this happens, you will imagine, okay, the graph is floating above x-axis. The solution set of the inequality, the solution set of inequality is, it's always floating, right? Everything will be greater than 0, but here you choose less than 0, so it's empty. In this case, the solution set becomes empty. No, nothing inside. Right? Nothing inside. Okay. Let's see another example. I want to give you one more example. If we do have, for example, let me make up an example. X squared minus 2x and plus 1 greater than 0. If I have this, if I have this, remember the leading coefficient is a positive, so it's okay. And then we try to factor it. So you will see that it's exactly x minus 1 quantity squared. You just consider negative 1 as, you consider 1 as negative 1 times negative 1. Negative 1 plus negative 1 is negative 2. Okay, then you will get one solution. I'm trying to say what happened with one solution. If there's only one solution, it's like this. Almost the whole graph is above x-axis, except this point. This is on the x-axis. So if you choose greater than 0, you have to exclude this point 1. You must exclude this point 1. So the solution set of the inequality is from negative infinity to 1, parenthesis, union from 1 to positive infinity. This 1 is the greater solution, so you're going to choose the right branch of the greater solution. 1 is also the less solution, so you're going to choose the left side of the less solution. So basically, by this trick, you just remove number 1 from the number line. Okay, so this is another extreme case. When you have a double solution and you're looking for the positive part, the greater than 0 part, you just remove it. If it is greater than or equal to 0, then that's the whole thing. So for example, if we are solving this inequality, including this equal sign, it means you will include this 1. If you include this 1, the solution set will be negative infinity to positive infinity, everything. Okay, so I'm going to use the same question, but just change this symbol a little bit, see what is the difference between the solution sets. Greater than 0, your solution set does not include 1. Greater than or equal to 0, your solution set will include 1, which will give us the whole number line. If here you choose less than 0, less than 0 means you're looking for the graph below the x-axis, but there's nothing below the x-axis. So the solution set is empty, or you use this symbol. Okay? So if you're looking for the problem like this, you go through here, you get the double solution, then less than 0, still it has empty solution set. And if you get less than or equal to 0, if you get equal sign, then there's only one solution, because only this solution just barely equal to 0, but no part less than, so the solution set is just 1. Okay, I hope I make this example clear. I have a fixed left side and the right side, but I try to change the inequality, and you will see what will happen when we change the inequality. The solution, what the solution set will happen when we change the inequality. For this double solution is slightly different from the other part, from the previous part. Okay, so do the exercise. Try to understand each step and be careful here. I emphasize, I just discussed the case A greater than 0. If A is less than 0, multiply that inequality by -1, change it to be greater than 0. Of course, when you multiply inequality by -1, you're going to change the direction of inequality. Less than to be greater than, less than or equal to be greater than or equal, or vice versa. All right? Okay. If you have any question, send me email. If I make any mistake, also send me email. Let me know. Okay, thank you very much. The lecture is not done, but the video stops here. We will continue in another video. Thanks.